All right, time for another DraftPhysics.com, debatephysics.com also, but you really can't debate mush and silly putty and, what is just mud throwers. They can't manage a physics argument of any kind. So it's all quite pathetic. So anyway, do a couple of mindless marbles comments that just won't make no sense at all. All right, so he says, why do people ignore at DraftScience? So I don't know why it's there, but anyway, because time and time again. So again, let's understand what ignore means. Cancel culture. Okay, I mean I could show you. Might as well. Um, let's see. So that's the comments. This should be the video. So we'll go to shorts here, and you should be able to see that. Yeah. Okay. So you can just see that, okay, my shorts were averaging 500 views, well, 480, let's say. And all of a sudden, just in one day, that one's got 746 views. In one day, all of a sudden, oh, 40, 30, 39, 40, yeah. And I've deleted and republished them over and over again a few times just to keep checking to see if this is a real thing. And some of these, the ones especially talking about Google, had an 87% click-through rate. So a gigantic, in terms of really huge amount of people would click on it because of the title, probably. So you can't say, oh, nobody's clicking on the videos or any kind of horseshit like that. So it's clearly, this is how the internet works. This is how these cancel culture people want it to work. They don't want to actually have to argue somebody's argument. They just want to shut them up. Okay, so they're the Inquisition, essentially. And, they just have to shut up anybody, put them in house arrest, take them off the internet, because they can't win the argument, clearly. All right, so this post by Mindless Marbles, I had it up. Yeah, it's here. Okay. So he says, okay, because time and time again, people understand that engaging with narcissistic crackpots. So let's understand their hero, that they won't admit is their hero. But anyway, Leibniz, okay, wanted to be called von Leibniz and wore the most pretentious, insane wigs anybody ever wore, just to, prove he was the greatest. So, and again, what logic can you apply to this? It's like saying somebody who is I don't know, likes having sex with dogs can't be a physicist. Or, some other kind of bullshit. How would being a narcissist have anything to do with whether or not a person can do physics or can roller skate? I mean, it's just such bullshit. I mean, it's such a small-minded accusation in the first place. But what petty nonsense. And again, coming from this arrogant, obnoxious troll who has obviously is so small and ugly, he won't make a video. Because yes, he doesn't want to show who he is. All right, with with only, okay, so not great at sentence structure either. Being in more and more lies and false accusations that other people will have to counter. Where do you counter any of the accusations? Where can I go find the counter arguments? Where? So let's say I make an accusation. Where do I go find these counter arguments? I don't see them anywhere. All right, and so he says the comment below was posted on Michael's video, so it's not even my comment, right? And you're saying, how can he? So it's not about narcissism; it's about complete delusional
This letter will give you five.
bullshit, right? I mean, again, a video with 135 views with commercials on it. I mean, who does that? Yeah, right. I mean, who does that? That's a rational thing to do. To bother people with commercials for 14 cents. I mean, 12 cents. I don't know. All right, so it's a very simple. So the bass and bass guy shows up and says something perfectly reasonable. Hey, so it's been several months now. All right, so several is probably the wrong word. You should say a few months now. This has been like 3. You said you were going to show a free momentum experiment using pendulums. So, again, do I have to actually play the clips? I mean, is anybody going to sit there and defend Mindless Marbles' statement basically that this isn't a fact, that the guy talked about buying the actual bigger metal things to do the experiment, talked about the fact that he actually did construct one, and he talked about the fact that, yeah, it was too wobbly. The balls are too heavy, so he has to secure it better. So all of those things were stated. He stated he was going to do the experiment. He stated that he had gotten the materials, and he stated that he had actually constructed it, and it was for some reason not quite right yet. Those are all facts. So where's the lie by Bass and Bass Guy? Where's the lie in here anywhere? Okay, and so he says, when can we expect it to be shown? So, and obviously it hasn't been shown, right? I mean, obviously the experiment we were promised hasn't been performed. All right, so Mindless says, try asking the question again, this time without lying or descriptive false premises. And so what's the false premise? That it has in fact been months. The experiment, he said he was going to do it. He has the materials, and he did partially do it, but he promised he was going to fix it. Well, where is it? So where's the lie? I mean, it's just an amazing pile of nonsense. And then the stupid Laska guy shows up to throw in this crap. Have you watched the one by Spar's lab? Right, the one with an 8-inch pendulum. Yeah, 8 inches. I think your free momentum is clearly visible there if you pay attention. So again, they're just such despicable propagandists, and that's all it's about. The whole point was him to do the experiment better. Okay, that's what we're waiting for, is a better example of the experiment, one that can actually be measured, not one so small and so confused by the irregularity of the pitch of the pendulum, the arc that it swings at. And so these people are just such full of bullshit. I mean, measuring the velocity on something that has such a small traveling distance is impractical when the velocity is constantly changing. Obviously, you can't get the instantaneous velocities correct. But whatever. That's physics, and they obviously can't do any physics. But I mean, just what's the point of the post? What the fuck are you? How can you make such a stupid argument? All right, so we'll go to his second post, this more recent one. I haven't read this one yet, so we'll see what this nonsense is. But I mean, these aren't counter arguments in any form. They don't deal with the facts at all. All right, so at 34:20, so he's posting a link to a video and then a point in the video. I mean, it's just such bullshit. I would imagine you could put the actual time code in here. Anyway, look at these priests all reciting the same script without about what these strange words mean. And they do. It's all they do, as pointed out. Lewin saw the monkey drop experiment, decide he'll do that too. Yes, I was just pointing out how I thought, all right, Professor Lewin's shtick was the fact that he invented these experiments, and that, these ways of demonstrating. And so I was giving him some credit for, the fact that he was pretty imaginative and these were pretty interesting experiments. And then I saw the 1960s videos and said, the MIT videos, and said, shit, these are the same fucking goddamn videos. I mean, and then you see some other colleges doing the same thing, the same monkey, same dropping. I mean, it's, there's no originality at all. All right. They're just mimicking each other. Yeah, so that's all nice. They're not doing anything innovative. Right, so it's like they're not really saying, here's the physics concept, how do I illustrate it, and then do that. Come up, that's what innovation comes from, is people doing things differently, not people doing things the same. Oh, amazing. They're not doing anything to really think about it. It's and says maybe this is wrong and maybe that should be, we should correct that. So, yeah, I think it's a perfectly salient point that obviously the physicists are just reciting the Bible and they're just simulating Bible stories, and there's no real thought about, well, what if the burning bush was actually just a bush with red leaves? Yeah. All right, the very next moment, okay, at 34:48, I don't know how many other physicists besides Professor Lewin think there's two voltages in the same place. Yeah, so I didn't say every single thing Professor Lewin did was a mimic. What I said is that I'm surprised that most of his experiments are. Okay, the radar experiment, mimic. The radio wave experiment, mimic, with a little light bulb, done in 1960. The monkey one. Let's see if I can think of some other one. But I'm just clearly pointing out nothing original here. So I guess he innovated that crap. Yeah, so my point is that obviously everybody had done the experiment. It's what he's concluding is different. He's claiming that those voltage readings are real voltages read at that location, when obviously the other physicists would say, no, my probe wires are in the experiment. I can't read the voltage with probe wires that are that are being hit by an inductor. That would be really idiotic of me to think I'm getting an accurate reading. But you can't even agree on that shit. I mean, one guy says from Fermilab that, well, single slit, that's diffraction. So these are all facts. I mean, it is, Fermilab guy says, let's ignore the single slit because it's diffraction. It's not the same phenomenon. And obviously, Professor Lewin made a whole speech in one of his videos where he pointed out, no, it's all the same phenomenon. It's Huygens, it's, interference, and it's ludicrous to sit there and say there's some distinction between what is physically happening in the two experiments. And then I would obviously interject, obviously Lewin's correct. I mean, it's just surface. You can't sit there and say, oh, this surface does diffraction and this surface does interference. It's a silly thing to say. And the double slit is interference, and then Professor Lewin says exactly the opposite. It would be nonsense to be some other mechanism causing the two effects. The two effects are obviously the same thing, and the two effects are caused by the same physics. So amazing. So because I pointed out how some portion of Professor Lewin's experiments aren't as imaginative as I thought they were, that means I said every single thing he ever says or does is exactly what somebody else says and does. No, that's not what I said. I mean, it's just so petty. All right, let's see. Does not have any important or interesting message to say, except that your physics is corrupt and unevidenced baby talk, that you people are religious kooks, and that's all you are. And you're acting like them. You're behaving just like jihadi Muslims. All right? You're not trying to defend the truth. You're not trying to protect the truth. You're trying to impose a fable. All right. He doesn't have any point. He just wants to talk out of both sides of his mouth and make himself seem superior. So I'm just pointing out facts. Now, the fact that the guy from Fermilab and the guy, Professor Lewin, are saying two entirely different things, that doesn't bother you. That fact, okay, that your scientists can't even agree, that doesn't bother you. You're sure they're both right. Fuck. I mean, it's just so pathetic. All right, so it's so pathetically ignorable as anything meaningful. All right, so I will move on to other things. So I have this on the board, so I might as well talk about this first. And then we'll get to all the little other details. So obviously what I have to do is make a list of questions, okay? But you have to word them so carefully, because you just saw how mindless marbles perverts anything you might say. All right, so you have to sit there and put all these qualifying statements in, because he'll just pervert everything. And it's, they're all so dishonest. All right, so we're back to this flat surface thing. Now, so this is one experiment. You're just saying, okay, I'm saying this is pretty decisive. All right, that you can't rationally, okay, in my opinion, you can't rationally argue what they argue. Because when you put the facts together. So you could just ask the question, do you believe that if I slide across thin ice quickly, that I put the same pressure on the ice that I would if I slid across it slowly, or not at all, if I just stood on it? do you think standing on the ice, right, is the same energy into the ice as sliding across the ice? Do you think that the same pressure goes into the ice? Now, I think you know it doesn't, all right? So I would say that in understanding friction in gravity, friction caused by gravity, linear friction, it would be just like understanding sandpaper, okay? And I could rub a piece of sandpaper across a surface and apply no pressure, very light pressure. Or I could run the sandpaper across the surface and apply a lot of pressure. Which one's going to do more work on the wood? Now, you know the one with more pressure. So the fact is we know that this going twice the velocity, okay, and this is one velocity. Again, we know this experiment is exactly the same as this. So the finish is always the same, all right? And that half the total time that the object will be putting pressure on the ground, half of the time is going to be putting pressure here. So this is half the amount of time that this object can possibly weigh something is in this little section, okay? And the other half has to be spread across this entire section. And they still are insisting that the pressure here is exactly the same as the pressure in this little section. And it's exactly the same as the pressure in this little section. And it's exactly the same as the pressure in this little section. Now, even though they can know that they can break this section, this whole section can also be cut, into quarters, and you'll end up with half the speed here. All right, and you can always do that. You can bisect each one of these, and here, and here. So this one is the fastest velocity. This is a little less, this is a little less, and this is the final velocity. And so we know that this is the least amount of pressure. So if I was to weigh it, this would weigh the least because it went across the scale the fastest. And then this would weigh a little bit more because it's going a little slower. And this would weigh a little more because it's going slower. And this would weigh the most. So you know that the sandpaper is barely rubbing the surface here. It's a little rougher here, it's a little rougher here, and it's a lot more pressure here. The same pressure you applied over this entire area is in this little area. So how can you really argue that this is a full unit of energy and this is a full unit of energy went into the ground? The same amount of heat or weight. It's not the same weight here and the same weight here and the same weight here and the same weight here, or the same pressure. Just like the ice argument. It's less pressure because you're moving across it quickly and you're putting less pressure on the ice. That's why the ice doesn't break. Clearly, less pressure here, a little more pressure here, a little more pressure here, and a lot more pressure here. So there's no way these can be equal units of energy, that each one of these is a unit of energy. No, there's only one. There's this unit of energy and this unit of energy. And that's perfectly consistent with dropping something 4 units of distance and getting 2 units of velocity. Because all you got was 9.8 here and 9.8 over this whole area. All right, 9.8 here, okay, for these whole 3, 9.8 here. And you see it in the velocity, 19.6. Come on. I shouldn't have to argue this. Okay, so another question. So do you believe that you can defeat thin ice by moving quickly across it? You have to, nobody's going to argue that no, you can't. Are they? Are they going to argue that you can't slide across thin ice and reduce the amount of pressure you put on the ice and therefore not fall through? And then are you really going to say that if I lift something slowly, I'm doing the same work as if I lift it fast? That it's the same work. If I take 100 pounds and I lift it quickly versus 100 pounds and I lift it over a whole day, I spend the whole day lifting it, it's going to be the same amount of work. I think it's not. And I think you're going to understand why it's not. It's because the fact is the longer I'm fighting the gravity, the more gravity I have to fight. I guess the other question. Do you think a rocket can lift off at 60 miles an hour and use the same fuel as if it got up to, say, 5,000 miles an hour? same amount of fuels be used. 60 miles an hour for the whole trip, or it goes to 5,000 miles an hour, it gets through the gravity in 1/100th of the time. I mean, obviously the rockets do go fast because they have to save fuel. They can't carry enough fuel to get into space if they don't go fast. They can't get there going slow. It don't work. I mean, you're going to deny that? And then to Ian Gosling, I mean, we've already been over this, but so if I bend something quickly, do I do the same amount of work as if I bend it slowly? So if I have a Bowflex, I have a flexible thing. I actually have something on my porch, a big spring. So I bend the spring really slowly. Am I doing the same amount of work as if I bend it quickly? Do you really think so? I mean, I think you know better. And so what are you defending? I mean, it's not a complicated argument. I mean, obviously, if you can understand that if I'm bending it slowly, I'm under constant pressure. The whole time I'm bending it, I have to resist the pressure. It keeps applying pressure, saying I want to spring back to being straight. And I have to keep fighting that pressure each second. More pressure, more fighting each second. And the quicker I do it, the less seconds of pressure I'm going to have to impose. I mean, it's so obvious. But, it's so obvious that your people are just despicably dishonest to sit there and say you have some pat solution or answer. You don't have an answer. You don't have a way to make these facts compatible. All right. It's just so annoying. Speaking of Ian Gosling, okay, so he's got an electric motor turning his wheel now. And he has wooden blocks on it and a pulley, so he really doesn't need the weights anymore, right? So he's already added enough extra weight. But regardless, so he's got an electric motor turning it. Now, why doesn't he just measure the amperage going into the electric motor? And then he can show us that it's 4 times the amps to go twice as fast, and 9 times the amps to go 3 times as fast, and 16 times the amps to go 4 times as fast, and 25 times the amps to go 5 times as fast. Why doesn't he just show us that? Yeah, okay. I think it's a good question. All right, the Joseph guy in the comments about the box experiment. So just for, the box experiment has these elements in it, so I might as well just go directly to these elements. All right, so we know that if we took a car, okay, so this is sort of a Mythbusters thing. They did this thing, okay, and you're going to allow it to be crushed. All right, so you have a crushable substance, clay, let's say. And you have a 50-mile-an-hour crash and a 50-mile-an-hour crash here. We have 2 arrows going into each other. And the fact is that this will crush just as much as if I hit it with a brick wall. So if I just hit it with crash it into a brick wall, it'll be the same thing for this car. And if I crash this car into a brick wall, it'll be the same thing for it. So, yeah, that's kind of interesting that, even though it's twice the energy of the impact, both cars only sustain the same energy would be 0. So there's no such thing, again, as positive energy when you have springs involved, because the springs or the compressible substance means that you've doubled the amount of stuff that can be compressed here. So obviously this can only feel that much because it's going to absorb that much energy, half the energy of the experiment, and this one's going to absorb the other half. Now, if you put the crushable between it, okay, and so now the thing you're going to crush, the clay, is in between the two, then you can understand, the clay is going to crush 100-mile-an-hour worth. Okay, so then it'll equal the same crushing that if I had a 100-mile-an-hour car crash into the brick wall. Okay, I'll get the same crushing as if I have a 50 and a 50. So if I move the wall, it's basically just saying, yeah, if I cut this speed to 50 and I have the wall move with the same momentum as 50, all right, so obviously it would be less. The wall would have to weigh the same as the car. I'd end up duplicating the same circumstance. So momentum works perfectly well. It's a perfectly rational idea. And direction is meaningless mush. Okay, because if I use a spring here, they'll both bounce back with all of their energy. So there won't be any zero outcome. All right, because I didn't allow anything to crush. So, again, it's just nonsense. So the idea is this simple argument that if you bounce a ball against a wall, this is their argument. If I bounce it and the ball bounces back 100%, right, then I put 200% into the wall. But if I throw the ball and it only bounces back 50% because the wall moved, okay, yeah, so the wall moves and I only get 50% back, right, then I only put 50% into the wall. So I have this gigantic degrade, okay, if something moves, and if nothing moves, I get this huge increase. Now, obviously, the whole idea that you're putting 200% of the momentum into something that didn't move absolutely makes no sense at all, right? I mean, how can you make any sense? How can I have momentum if it didn't move? Well, they're arguing the whole Earth moved, okay? I moved the whole Earth. And again, so this goes back to the ball bouncing on the anvil. I mean, it makes no sense at all. I can bounce the ball on top of the anvil 1, 2, 3, 4, 5, 6, 7. It can keep bouncing. And each time I'm putting 2x the momentum, 2x the momentum, 2x the momentum, 2x the momentum with each bounce. So I'm putting in 50 or 60 times the total momentum into the ground, into the earth. I mean, it's nonsense. All right, so to the idiot. So as the best I can read his moronic comment, okay, which is something like, well, the extra energy goes into the other object, not the box. All right, so we're back at this idea. We have a spring. We push the 10 mass, and we push the 5 mass. And so he's just contriving nonsense to try to evade the whole subject, really. And the idea is the 5 mass and the 10 mass are going to hit at the same time. And the problem is that you have 250 joules of energy here, 125 joules here. You have the same momentums, but these different joule numbers in kinetic energy. And obviously that would mean that 500 joules is going into this wall, and only 250 joules is going into this wall. Now he says, oh no, that doesn't happen, because of some magic that, somehow when this one hits, it'll undo whatever this one hit. Well, they're still opposite joule numbers, so how could that even be? But the trick would be I could just let this one hit first. Okay, so the simple truth is I could make this wall in a little bit. Okay, I could just bring it closer. So this one hits first, and so then the whole thing has to move with the extra momentum, joule number, twice the joule number. Okay, and then this one hit a little bit later, so I extended this wall, and so this one hits a little bit later. All right, so this whole mass is now moving. So now instead of just having 125 going against a brick wall, right, a wall that's not moving, now the wall's moving towards it. And his argument is that somehow this is still going to reflect with 125. So it reflects with 125, right? That's all it has, is 125 when the wall's not moving. And he's claiming that when the wall is moving, somehow it's still reflecting with 125. When obviously that doesn't happen. So if you throw a ball in a moving car, for example, a rubber ball, kind of a shitty car, but whatever. And so what's going to happen? So say I throw the ball with a velocity this way into the car. What am I going to get back? Well, if the car's not moving, I'll get back what I put in. That's it. But if the car's moving, I'll get back in this ball not only the reflection, so let's say this was 30. I'll get back the 30 plus the momentum of the car, that is the velocity of the car. So if the car is going 20 miles an hour, I'll get 20 on top of that 30, and I'll get 50 back. So I'll take a little bit of the car's energy, a tiny bit of its momentum, will boost the velocity of the ball, just as if the ball wasn't moving, and it hit it, and it gave it a velocity. And this reflection will still be there. So I'll have a total of 50 in velocity coming back with the ball. That's how the real world works. You can't move this whole surface towards this object and not have the object reflect with more energy. It has to reflect with more energy because you're moving the goddamn wall towards it. It doesn't have a choice but to absorb the energy of the moving wall. So now you have the same problem. Now you got something going whatever amount here, let's say 225 or whatever joules of energy going this way. So the box still has to move this way. He's just such a pathetic liar. Because this is going to hit back on this and give it the energy. There's no way you can undo the creation of your fake joules. You can't just make them disappear. Oh, just all this is just so horrible. I have to have all these arguments over and over, and they just keep insisting. So, yeah, I guess I'll do one more argument. All right, so let's just do that simple gravity one more time. So you have a gravitational body, and you're just going to say, look, there's a point A here, okay, very little gravity here, okay. The strong gravity is going to be here, between these 2 points, A and B. This is the strong stuff, and this is getting weak by the inverse square law. And we're just going to go from point A to point B. And the simple truth is the faster I do that, the faster I can get from point A to point B, the less this will happen, the less bending there'll be. And the slower I go, the more likely it is this distance gets longer and longer, short, longer, longer. And because the planet's here, obviously I don't get to go as far because I'm going to be crashing into it at a high speed. Because I'm going so slow, I'm going to be affected by a lot of time of gravity pushing. So that's how it actually happens. So gravity is clearly a time-dependent force. You get it in chunks of time. A unit of time, 9.8. Unit of time, 9.8. Unit of time, 9.8. That's how it works. It's per a unit of time. It's 9.8 meters per second of velocity per every 1 second. That's the actual formula, and that's how it actually works. And so, obviously, when you're rolling something across a surface, it's the same argument. The slower it's going, the more gravitational force is falling on it. It's collecting it like rain. The faster it goes, the less weight it collects from the gravity, okay, and the less force it puts into the ground. So faster it goes, less force. Slower it goes, more force into the ground. I don't see how anybody can rationally dispute that's an absolute fact. The faster you go across the surface, the less force pushing you into that piece of surface. The surface feels less pressure. And the slower you're going, the more a piece of surface feels the pressure. Clearly, less friction, the faster you're going. Less transfer of energy. So there's no way there can be 4 units of energy in 4 times the distance, because 3/4 of the distance is the same amount of gravitational pressure as 1/4. I can't believe people are too stupid to understand these arguments. I don't know how to make them simpler. Again, their physics is basically saying you can't not fall through thin ice. Going faster will not help. You will fall through the ice no matter how fast you go across the ice. That's what they're claiming is an absolute fact. And you know it's not a fact. So why are you agreeing with that claim? I don't know. Too stupid. Alright, might as well read the silly comment from the silly person, the Joseph guy, since he's engaging in this again, why, none of these people can make videos. None of these people can draw anything. It's just pathetic that nobody can show up and draw their physics. No one. All right. So he said, so this guy, the Spirit Mind said, have you tried to be more vague? Yeah, because he's making this vague accusation. And then he basically concedes that, yes, he was wrong, that the 2x thing is what physics says. So this is the funny part. Sorry about that. It is true if an object bounces into the opposite direction with the same speed, the change in its momentum is twice its original momentum in the opposite direction. So he's basically saying that somehow changing direction costs energy, when the simple argument is, of course, it doesn't cost anything. That's why the ball can bounce on the anvil 200 times, is because it doesn't cost anything to change the direction. Okay, the lever proves it doesn't cost anything to change the direction. So if you have an ideal lever and you put a 2 pounds here, and you have a 2 pounds, and you drop the 2 pounds on this side, the 2 pounds flies off in the opposite direction and you didn't lose anything. All right, and it's true that an equal but opposite change in the momentum must happen somewhere else to conserve momentum. So here he says it again. We're not talking about conserving momentum. We're talking about the existence of your silly kinetic energy. You need to conserve the kinetic energy, and you can't do it. And that's the simple truth. You can't. All right, in the box experiment, it is the other object that experiences the equal but opposite change in its momentum. So it just doesn't make any sense. That means it's got to be going with a huge amount of joules in the opposite direction. That means it picked up energy, is now going this way with more energy, and is going to hit the other side with more energy. So again, it's just bullshit. Oh, I mean, these people it's just horrible. They get away with this crap. This simple-minded, reference to no experiments, reference to no drawings, referencing to no modeling, references to no simulation, references to nothing. And they just keep saying, oh, yeah, no, it happens. Yeah, I can't prove it. I can't show you. So again, you're just going to keep telling me 4 pounds dropped 1 foot is the same weight, the same pressure imposed on the ground of 1 pound dropped 4 feet. But you don't think you ever have to prove it. It's just... If that isn't the definition of an anti-science statement, this idea that you don't have to prove it, you don't have to do the experiment. Oh, okay. Well, I say bullshit to that. That was your obligation. You have all the laboratories, you have all the scientists, you have all the money, and you can't drop 4 pounds 1 foot and 1 pound 4 feet. With all of those scientific resources, Fermi Lab just can't afford to do that experiment where they drop the 4 pounds and then drop the 1 pound, and measure the temperature or measure something that'll tell them the weight or the pressure applied by the object, the energy the object has. They can't collect the energy. All right, it's just such bullshit. Alright, so fuck you and such. Until the next time and whatever. God, a planet of fucking idiots. I just had no idea so many people were so fucking dishonest and stupid. Very disappointing.